Hey everyone, we live in a world that absolutely runs on data, right? But the thing is, the quality of that data, that's everything. So today, we're going to dive into some really cool research that's basically assembled an AI detective squad. Their mission, to hunt down the one thing that can mess it all up: bad data. I mean, think about it. Are tiny errors causing billion-dollar problems? It sounds dramatic, but the answer is yeah, almost definitely. A flawed business plan, a wonky machine learning model, these things can start with just one tiny data error that snowballs into something huge. So the real question is, how on earth do you find these little culprits when they're hiding in literal mountains of information? All right, so let's get into it. Before we can really appreciate our AI detectives, we've got to understand the crime scene. And trust me, it's a big one. We're talking about the massive, super complex world of data warehouses and the tiny little clues that tell you something's off. So, what is a data warehouse? The easiest way to think about it is like a company's giant central library. It's got everything, all the crucial books. Sales figures, inventory levels, what customers are doing. Basically, all the information you need to make those huge, sometimes billion-dollar decisions. But here's the catch, right? What happens if some of the books in that library are just wrong? It's that old saying, garbage in, garbage out. The insights you pull out are only as good as the data you started with. If your source material is flawed, any strategy you build on it is gonna be shaky. And that is the real challenge here. How do you find those few corrupted books among millions of perfectly good ones? So in the data world, we call these corrupted books outliers. And an outlier isn't always just a simple typo. It's any data point that just doesn't fit the pattern. It could be a mistake, sure, like a data entry error, but it could also be a red flag for fraud, or, and this is cool, it could be a clue to a brand new, super important trend. They're basically the little mysteries hiding in the data that we absolutely need to solve. And trying to find these things the old way? Man, it was like trying to find a specific needle in a haystack the size of a continent with a pair of tweezers. Seriously, the traditional methods used these really static, inflexible rules that just can't handle the massive, constantly changing, super complex data we have today. They're slow, they're clunky, and they miss all the really subtle stuff. So if the old way is broken, what do we do? Well, a modern problem needs a modern solution. And that's where this gets really interesting. Let's meet the high-tech team that this research put together. It's a framework that uses multiple AI models, and it works just like an elite detective squad for your data. The big idea behind this is something called an ensemble method. It's actually a pretty simple concept. Instead of just relying on one detective who has their own way of looking at a case, you assemble a whole team of specialists, right? Each one brings a unique skill to the table, and when you combine all their different perspectives, you get a way more accurate and reliable result. Teamwork makes the dream work, basically. And this is our squad. Each one is a different kind of AI model with a special job. First up, you've got what we'll call the neighborhood watch. It basically looks at a data point and its immediate neighbors to see if it looks weird, out of place. Then you've got the interrogator, a model that's really good at quickly asking a bunch of questions to isolate suspicious data. Next is the bouncer. Its job is to draw a really strict line around what's normal and flag anything that dares to step over it. And finally, we have the profiler, which might be my favorite. It actually learns the signature of your normal data and then flags anything that doesn't fit that profile. Okay, so here's the real magic. The power isn't just in having this team, it's in their consensus. It's about making them agree. Think about it. If one detective flags something, okay, that's interesting. But if 3 or even all 4 of them are all pointing at the same piece of data saying, hey, look at this, well, now you've got a really high confidence lead. That's a case you need to investigate. And check this out. This is that process in action. So they took a sample inventory data set, and look at these numbers. If you just listen to any one detective, you're left with almost 69,000 potential problems. That is a lot of noise to sift through. But if you change the rules and say, I only want to see the cases where at least 3 of my detectives agree, boom, that number drops all the way down to just over 5,000. It's an amazing way to see how that consensus just cuts right through the noise. And that's the final number. Out of a massive sea of more than 776,000 records, our AI detective squad zeroed in on just 5,229 really high-confidence anomalies that genuinely need a closer look. That is the power of precision. But finding the problem, that's really only half the battle. So what's the other half? Well, this is where the whole framework goes from being really clever to being a total game changer. Because it doesn't just tell you what is wrong, it's actually designed to tell you why it's wrong. And the secret weapon for this is a tool called SHAP. The best way to think about SHAP is like the detective's final case report. After the squad flags a suspect, SHAP comes in and lays out all the evidence. It tells you exactly which features, which parts of that data point made it look so suspicious in the first place. It literally makes the AI's thinking transparent. And this comparison just makes it crystal clear. The old way, you'd get a vague alert, something like, hey, anomaly found in currency data. And you'd be sitting there thinking, okay, so what do I do? But the new way, with SHAP, the alert is completely different. It says, anomaly found because the end-of-day rate was way too high. See the difference? All of a sudden, you have something specific, something you can act on. You've gone from just detecting a problem to actually diagnosing it. And here's a perfect example right from the research. They were looking at sales quota data, and SHAP pointed its finger directly at one thing, the sales amount quota feature. It was the biggest red flag. It turns out that values in that one column that were either way too high or way too low were the main reason something got flagged. That's incredibly useful. It tells a business exactly where to focus their efforts to fix their data. So let's zoom out. What does all of this really mean for the future of data? Well, we're talking about a pretty fundamental shift here. A whole new way of thinking about how we keep our data clean and trustworthy, and by extension, how we trust the decisions we make based on that data. And listen, this matters so much because it's way more than just cleaning up a spreadsheet. This is about going from just spotting problems to actually understanding why they happened, their root cause. It means you can make these really targeted surgical fixes. It builds real trust in your data, and maybe most importantly, it starts to crack open that AI black box. It turns AI from this mysterious thing into a more transparent, understandable partner in the process. And really, that's the core message here. At the end of the day, this isn't just some cool tech tool for data engineers. It's a blueprint for building a real, working, trustworthy relationship between us, the human decision makers, and the powerful AI systems we're starting to rely on more and more. And that really leaves us with a huge question to think about, doesn't it? As AI gets woven into pretty much every part of our lives, how are we going to make sure that it can always explain itself? The demand for this kind of transparency, for explainability, it's just going to explode. The future isn't just about making AI smarter. It's about making AI that we can actually understand and truly trust. Thanks for tuning in.